Solve for x on the integral where x is from 0 to 2 pi inclusive. So problem number 1, we have sine of angle x is equal to square root of 3 over 2. So this is similar to what we did yesterday. We have to figure out what angle has a square root, what angle has a sine of square root of 3 over 2. And what would that angle be? Pi over 3? Which would be 60 degrees. Now, make sure our interval is in radians. So don't use 60 degrees. Your answer needs to be in radians. Now, that is only half correct because sine is positive in quadrant 1. And which other one? Quadrant 2. So what would that other angle or second answer be in quadrant 2? 2 pi over 3. So just like yesterday, make sure you list your answers from least to greatest. So pi over 3 and 2 pi over 3. Next one, number 2. We need to figure out what angle has a cotangent of negative square root of 3. Instead of cotangent, I can change that to tangent of x is equal to, if this is negative square root of 3 over 1, the reciprocal would be 1 over negative square root of 3. Rationalize that to multiply both the numerator and denominator by the square root of 3. That gives us that the tangent of x is equal to square root of 3 over negative 3. So what would that reference angle be? Pi over 6. Well, pi over 6 would be the reference angle, but the tangent is negative. So in which quadrants would tangent be negative? 2 and 4. So we need to have an answer in quadrant 2 and 4. So the reference angle is pi over 6. What would that angle be in quadrant 2? 5 pi over 6. And what would the angle be in quadrant 4? 11 pi over 6. So 9 pi over 6 and 11 pi over 6. Okay, number 3, we have to figure out what angle has a sine of 0.8191. Is that a unit circle value like square root of 3 over 2 or 1/2? No. So if it's not a unit circle value, then you'll have to use the calculator. So since this is the answer for sine, this is also called arc sine. So we put this in the calculator, you'll have to do second sine. But the first thing you need to note is that this number right here, this is in radians. So you need to make sure that your answer is in radian mode. So first thing, make sure you're in radian mode. So if you're in degree mode, you won't be getting the same answers as us. So step 1, make sure you're in radian mode. And now, this is the answer for sine. So we need to do second sine. So type in second, and then hit the sine button. And once you do that, your calculator will say sine to the negative 1 power. And we need to do second sine of 0.8191. And this will be our first answer. So I'll label it as x1. And we'll round these answers today to 3 decimal places. And to 3 decimal places, what did you get? 0.960. Yeah, 0.960. So that is our first answer. But how many answers have we been having on problems 1 and 2? 2. And that's because sine is positive in quadrant 1, and where else? Quadrant 2. So first of all, I have to figure out, is this the answer for quadrant 1, or is this the answer for quadrant 2? So let me draw a picture. So there would be our angle in quadrant 1, and all of these angles are in standard position, where the initial side is on the positive x-axis, and the terminal side is going to either terminate for sine in quadrant 1, or quadrant 2. angles today will be with positive rotation. Because it said it has to be, but they said angle X is between 0 and 2 pi. So they're using positive rotation. Okay, so 0.96. Well, first of all, I need some values. We know that over here, this is pi, and what is the decimal approximation for pi? 3.14 approximately, right? So up here at the top, this is pi over 2. So half of 3.14 would be about what? 1.57. So at the top, pi over 2 is about 1.57. And on the left side is about 3.14 pi. So if our previous answer was 0.96, was that the angle that terminated in quadrant 1? Or is that the angle that terminates in quadrant 2? Yeah, this is 0.96, it's smaller than 1.57, so that's definitely going to be our first angle. So this is x1, and we estimated it to be about 0.960. Okay, now this has to be x2, our second answer. So angle 2 is going to be the one that terminates in quadrant 2. Now, x2 is this entire angle in red, from the positive x-axis to this terminating side. So if we're looking for this angle, how can I solve for that angle? Yeah. Right here, if this is 0.96, what is this angle right here, my reference angle? Yeah, well, let me draw it down here. Our reference angle is about 0.96. That's going to be right here. So if I'm looking for this angle in red, if from here to here is 3.14, I need to subtract off that reference angle. So to find x2 is going to be pi minus our reference angle, which we estimated to be about 0.96. So just use your estimated answer. Make sure you use the pi key, don't use 3.14. So do second caret key for the pi symbol, and subtract 0.96. And we're still going to round to 3 decimal places. And to 3 decimal places, what would our answer be? Yes, I agree, 2.182. And we'll do plenty more that look like that. Next one, number 4. Number 4, we have cotangent of x is equal to negative 1.280. Do we have a cotangent button on these calculators? No, we only have sine, cosine, and tangent. So we'll have to change this to the reciprocal. So cotangent of x, the reciprocal would be tangent. And if this is negative 1.28, I'm going to make it over 1. And the reciprocal would be 1 over negative 1.28. Now this is the answer for tangent. So this is the arctan value. So in the calculator you'll have to do second, and then tangent. And once you do that, your calculator will show tangent to the negative 1. And then inside the parentheses, you need to do 1 divided by negative 1.28. And we'll round to 3 decimal places. And the 3 decimal places, what do you get? Negative 0.663. Negative 0.663. I got that same answer. Negative 0.663. Now, what does the instruction say? Yeah, our answer has to be from 0 to 2 pi. Well, 0, is this a number bigger than 0? No. So is that going to be my answer? No. So let me draw a diagram so we can better see what's happening. And in which quadrant is tangent negative? Quadrants 2 and 4. So again, our initial side is going to be the positive x-axis. And our terminal side, so here is one angle. And it's also positive in quadrant 4. So back to our previous answer, negative 0.663. Now remember, that's our angle. So if my angle is negative, did I rotate counterclockwise? If your angle is negative, that means we rotated counterclockwise. So this negative 0.663 is actually this portion right here. But is that what we want? No, we want this outer angle. Well, I know one complete revolution is what? 2 pi. So knowing that one complete revolution is 2 pi, and this little reference angle is 0.663, how would I find this angle, x1? Subtract. So for x1, it's going to be 2 pi minus 0.663. Again, make sure you use the pi symbol. So type that in your calculator, 2 pi minus 0.663. And to 3 decimal places, what would that be?
5.620.
Yes, 5.620. So there's one answer. How many other answers do we need? One more. So we found the answer for quadrant 4. Now we need to figure out what would the answer be for quadrant 2. So this angle is x2. Well, I know from here to here is how much? Pi. So how could I find this angle right here? This entire piece is pi. From what? Well, the answer that we just got was for this angle right here. Now, if this is 0.663, that's my reference angle. So if over here, if this part is 0.663, what is this part over here? 0.663. And knowing that from 0 to 180 degrees is pi, how could I find x2, that angle in red? Subtract it from pi, so subtract that reference angle from pi. So x2 is going to be pi minus our reference angle, which is 0.663. So pi minus 0.663. So 3 decimal places, what did you get?
3.885.
That's not what I got. I got 2.479. 2.479. 2.479. Now we're using this rounded answer, so if you got something different, you might have used your previous answer. Instead of 0.663, you might have used that entire piece instead of the rounded portion. So to find your angles, you're either going to be adding the reference angle to pi, subtracting it from pi, or subtracting it from 2 pi. It's really just based on the location of the terminal side and where is your reference angle. So really the best thing I can tell you is to draw yourself a diagram. Okay, number 5 is a little bit different. What you have to do with number 5 is first get the trig by itself. So what would be the first step to get cosine by itself? Subtract 9 to both sides. So this would be 3 times the cosine of x is equal to -2. And divide both sides by 3. And that gives us cosine of x is equal to -2/3. And this is the arc cosine value, so in the calculator you'll have to do second cosine. And then inside the parentheses, you need to type in -2 divided by 3. And to 3 decimal places, what would that be? 2.301. I'll call this x1 is 2.301. Well, cosine is negative in which quadrant? 2 and 3. So I have to figure out, is that the angle in quadrant 2 or in quadrant 3? I'm going to draw myself a diagram, because that will help me figure this thing out. So I know cosine is negative in quadrant 2, so here's my initial side, here's the terminal side, and cosine is also negative in quadrant 3. And we said over here, this is pi, which is about 3.14. This is about 3.14. So if our answer was 2.3, is that the answer for quadrant 2, or is that the answer for quadrant 3? Yeah, it's smaller than 3.14, so this is our answer for quadrant 2. So here is x1, so we need to solve for x2. So we need to figure out what is this entire angle. Well, it's going to be pi plus this little extra. So we need to figure out what is this reference angle here. Well, it's going to be the same reference angle that was on the previous angle. So if this entire angle is 2.301, how could I figure out the value of this reference angle right here? Subtract it from pi. So for our reference angle, we need to do pi minus 2.301. And to 3 decimal places, what would that be? I agree, 0.841. So over here, this is 0.841. Hang on, my pen froze. Oh, it's empty. Fix it next. There we go. So this angle is 0.841. Down here, this is also 0.841. So if I'm trying to find x2, what would I have to do? Add it to pi. So for x2, this is going to be pi plus 0.841. And pi plus 0.841, the 3 decimal places would be 3.983. 3.983. Now, if you're off by 1,000, am I going to dock you a whole bunch of points? No, because I don't know if you use the rounded answer or if you use the exact answer. So if you use the exact answer, that would tell me, or I'd be able to see that in your answer. So if you're off by 1,000, I'm not going to do anything about that. Okay, next one, number 6. Get the trig by itself. So what would we have to do? Add 5 to both sides. So this would be 4 cotangent of x is equal to 5. Divide both sides by 4. So that gives us the cotangent of x is equal to 5/4. And do we have a cotangent feature on the calculator? No, so the cotangent, use the reciprocal, so this would be tangent of x is equal to 4/5. And we'll have to put that in the calculator, so second tangent of 4 divided by 5, or second tangent of 0.8, whichever you prefer. And to 3 decimal places, what would that be? I agree, 0.675. And that's one of our answers, but tangent is positive in how many quadrants? 2. So we need to find that second answer. So I'm going to draw a diagram for both so I can figure out which answers do I have currently. And tangent is positive in which quadrant? 1 and 3. Notice when I'm drawing these should have the same reference angle. So quadrant 1's reference angle should be the same down here in quadrant 3. So if my answer was 0.675, and I know this is 3.14, half of 3.14 was 1.57, if my answer is 0.675, is that the answer for quadrant 1 or for quadrant 3? Yeah, if it's smaller than 1.57, that's our answer for quadrant 1. So this is x1, which is about 0.675. So this angle is our second angle, so I'll label that one x2. And if I'm trying to find x2, how would I find this entire angle? Add pi to what? Yeah, this is the same reference angle. So if this is 0.675, this is also 0.675. So pi plus 0.675. And we'll round to 3 decimal places. And to 3 decimal places, what did you get?
3.817.
I agree. 3.817. So find the reference angle, either add it to pi, subtract it to pi, or subtract it from 2 pi to find your second answer. And a diagram helps. Okay, for number 7, we need to get the secant by itself. So to get secant by itself, what would we have to do first? Add 1 to both sides. So that gives us 3 times secant of x divided by 5 is equal to 1. And how can I get rid of that 3/5? Multiply both sides by 5/3. So that gives us secant of x is equal to 5/3. I want you to solve number 7. So you finished number 7. You should have 2 answers. Instead of secant, we should change that to cosine. So this would be cosine of x is equal to 3/5. So second cosine, and what did you get? 0.927. So that's answer number 1. Now cosine is positive in which quadrant? 1 and 4. So again, up here is 1.57, 3.14. So if our answer was 0.927, is that the answer for quadrant 1 or for quadrant 4? Quadrant 1. So this angle is x1, which is 0.927. So this angle at the bottom would be x2, but we want this entire rotation. And what is this piece right here? 0.927. So if that piece is 0.927, how would I find that angle in red? Subtract that from 2 pi. So for x2, it's going to be pi, not pi. We said it was 2 pi for one complete revolution. So 2 pi minus 0.927. And the 2 decimal places, not 2 decimal places, we're doing 3 decimal places. So the 3 decimal places, what did you get? 5.356. We agree? Yes? Yes? Okay. Okay, the last section. Now the instructions change for us. And it says to solve for the functional values of x. So this is a recap of what we did yesterday. If it says functional or principal values, it's the same instruction. And we learned the intervals yesterday, and we said sine is functional from what to what? Negative pi over 2 to positive pi over 2, inclusive. So negative pi over 2 could be an answer. Pi over 2 could be an answer. And what about tangent? Yeah, negative pi over 2 with parentheses. Negative pi over 2 cannot be a solution because that's where we have asymptote, as well as positive pi over 2. And cosine is the odd one, and cosine is functional from what to what? 0 to pi. So if they ask me for a cosine functional value, did I say 4 pi over 3 for an answer? No, that's not functional because it's bigger than pi. So make sure you check your work. Okay, so same thing we've been doing. Step 1, get the trig by itself. So what will we have to do first for number 8? Add 1 to both sides. So 1/2 times secant of x is equal to 1. And instead of dividing by 1/2, I'm just going to multiply both sides by 2. And that gives me secant of x is equal to 2. So if the secant is 2, what is the cosine? 1/2. Now we've been using the calculator with all of these because they weren't a unit circle value. But what about this one? Is 1/2 a unit circle value? Yes, it is. So I need to figure out what angle has the cosine of 1/2. Yeah, 60 degrees, which would be pi over 3. And I need to check my answer. Is pi over 3 between 0 and pi? Yes, so that is the solution. Pi over 3. Now, would I have the solution for quadrant 4? No, even though cosine is positive in quadrant 4, would quadrant 4 be between 0 and pi? No, so not functional. Whoops, what's too far? Number 9, get the trig by itself. So the first thing we would have to do is add square root of 2 to both sides. So that would give us 2 times the cosine of x is equal to the square root of 2. Divide both sides by 2. And that gives us cosine of x is equal to square root of 2 over 2. And what angle has a cosine of square root of 2 over 2? Pi over 4. Now, cosine is also positive in quadrant 4, but is quadrant 4 between 0 and pi? No, so the only functional value is pi over 4. And number 10, get the trig by itself. So step 1, divide both sides by 3. That gives us cosecant squared of x is equal to 4/3. But I don't want cosecant squared. I need to get rid of the square, so the inverse of squaring would be square root the square root of the left side, square root of the right side, and the square root of cosecant squared would just be cosecant. Okay. And when you square root, don't forget the plus or minus. If you square root, don't forget you have the positive square root and the negative square root. And when you square root a fraction, you square root the numerator, square root the denominator. So what's the square root of 4? 2. And when we square root the denominator, I'm just going to leave it as square root of 3. But instead of cosecant, I should change this to sine. So the sine of x will also have the plus or minus. And when I invert that fraction, the reciprocal would be square root of 3 over 2. So now, my answer could be in all 4 quadrants, because sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. So now I have the entire coordinate plane. But I have to remember my functionality. So sine, not sine, we're talking about sine here. Sine is functional from what to what? Negative pi over 2 to positive pi over 2. So should I have an answer that's in quadrant 2 or quadrant 3? No. So don't worry about quadrant 2 or quadrant 3. But in quadrant 1, what is the angle that has a sine of positive square root of 3 over 2? Pi over 3, 60 degrees. So that's our answer in quadrant 1. What would our answer be in quadrant 4? If I did 5, I heard 5 pi over 3. Is 5 pi over 3 within this interval? No, so instead of 5 pi over 3, it needs to be negative pi over 3. So instead of, I already have the positive, someone just put a plus or minus out in front. So our answers are positive pi over 3 and negative pi over 3. So we have an answer in both quadrants. So it's possible to have more than one functional value, and that typically happens when you have to take the square root, because you'll have a positive solution and your negative solution. Okay, last one. Get the trig by itself. So divide both sides by 3 square root of 3. So that gives us tangent of x is equal to 1 over square root of 3. Rationalize that, which would be square root of 3 over 3. Now, talking about tangent, where is tangent functional?
Negative to positive pi over 2.
Yeah, negative pi over 2 to positive pi over 2, not inclusive. So our answer can only be in quadrant 1 or 4. First of all, in quadrant 1, tangent is positive or negative? Positive. What about quadrant 4? Negative. So will we have an answer in quadrant 4? No. So only quadrant 1. And what would that answer be for quadrant 1? Pi over 6 is right. So pi over 6, this tangent is square root of 3 over 6.